Right. So yeah, like I said, the previous week we've been, introduced to SQL, but kind of from the user perspective, writing quite assuming that everything already exists, you have a database, it's populated. How do you write queries? How do you, ask questions of this structured data? And we're going to switch now this week into actually building those databases. All right, so we're gonna we're gonna start from a contrived example. So take a minute, look at this, and then we're just gonna ask some questions about, how would we talk about this? What kind of application is this serving, etc. Okay, so if you had to give this table a name, what kind of what name would you give it?
Some kind of e-commerce table, looks like.
Yeah. Hmm. Yeah, it does. It does look like it's some kind of e-commerce. It's got, stuff is being bought.
Just call it customer order, I guess.
Customer order. Okay. So why would you call it customer order?
Looks like there's an order item and then an item number and then how much it cost and the order total and everything.
But why customer order?
Because there's also the customer listed, I guess, Sally and Bob.
Okay. All right, cool. So yeah, I'm going to focus mostly on ultimately like creating relationships here, but there's also something we said. Do you see any information here that is redundant?
I mean, I don't, not really.
Oh. Okay.
Same.
I mean, it looks like it's two things put together. I mean,
Yeah.
the
Okay.
the customer should be separate, and then the order should be separate.
Okay.
It's a separate table, like a checkout table, put together with two other tables.
Okay. Good. So we'll talk about that in a little bit. But for now, what about age and birthday?
Yeah, I guess that would be a redundancy.
Yeah.
So the question, so first off, this might not be the best name for this column. It looks like it's more birth year than birthday. So that's one issue. But let's say this birth year, if I know one of these pieces of information, I should be able to derive the other one. So this process is called normalization. So if you ever read up about database design, in a more formal setting, you'll hear about normalization, and there are these normal forms which you don't need to worry about. But the basic idea is you want to eliminate repetition. So just like we do in the rest of our code, you don't want to repeat the same information. If you don't want to store redundant information. And then there's also questions like if Sally Smith has another order, then I have her name and her address and her age and her birthday again. So if she orders 1,000 things, I have 1,000 copies of her name and address and birthday. And maybe I don't need that. Maybe I'm just like wasting storage space. So I'm, repeating myself over and over and over again. And then there's also the issue of, well, what happens if some of this changes? So after 1,000 orders, Sally Smith changes her name, or she moves. Then we have an issue where we have a single entity, a single user now has multiple addresses, or a single user now has multiple names. So that can be difficult. Like, how do you handle that case? Do you then have to go and update all the rest of the data? And that, that just creates a whole mess. So the ideal is to pull everything out into entities and then reduce duplication. So that's the kind of top level goal of creating a database design, but we're going to start from the bottom and work our way up to something closer to that. So the first thing I'm going to do, here's a link to the challenge, and then in the link to the challenge, there's a link to this database diagramming tool, which I'm going to use. So you don't have to use, interesting. So you don't have to use this, but you should use something. So whether it's drawing on a piece of paper or some other tool. So before you do any coding, especially with database, you should always draw something up. So I'm going to draw up this table first. So we have, you can call this anything, e-commerce, I think, customer order or something like that. So there's a little bit, there's a slight learning curve for this particular tool, so you don't have to use this, but it's a couple conventions. So, but anyway, so I'm just going to use this. You don't need to become like an expert in this or anything like that. Just watch. Okay, so we've got a few fields: ID, name, address, etc. So ID, name, address. What else? Birthday, order item. Order item number, order item cost. And the last one, order total. All right. And then Postgres not only allows you to define a table like this, but we also want to know like what type of data. So what type of data is ID? What type of data is name? And Postgres and any other database is going to have. Let's see. Here we go. A list. We're going to have a whole bunch of different kinds of types. So here are some big int, big series. You don't need to worry about all this, but integers, strings. There's all kinds of custom ones: money, numeric, path. This is a geometric path on a plane, so all kinds of timestamp formats and stuff like that. So there's a lot to choose from. We'll just keep it simple and say that ID is an integer. Name is a string. So string is varchar, like varying character. And then same thing with address, varchar. Birthday, let's say it's an integer. The year, order item. What was that? So it's a string and then some integers. Okay. So we have kind of a visual representation of this database. So now what I want to do is I want to translate this into an actual SQL table. And to do that, I'm going to do a couple things. So I'm going to use a tool called dbeaver. There's a few similar kinds of things. It's basically a GUI for interacting with databases. So it makes it a little bit more pleasant than PSQL, the command line tool. Since I'm going to be doing a bunch of different queries, I'm going to use this. There's also pgadmin, so for Postgres specifically, that is also fine. dbeaver is like free and you can use it on lots of different kinds of databases. Okay, so I have this open. Now what I want to do is I need to get a Postgres, container up. So I could do this locally on my machine, but I'm not going to. I'm going to use Postgres, Postgres Docker image. So I'm going to go Postgres Docker. And go here. And I'm just going to grab, here's an example command to run container. So that should be fine. I'm going to copy that. And then let me so I'm going to go ahead and copy that command. So if we analyze the command docker run and then an image, that's the basic command. So docker run and then the image we want to run. -d. What is -d?
Is that running it in the background?
Yep. Yeah. It's like as a daemon or a background process. And then what is this -e?
Environment variables, I think it like overrides them.
Yep, exactly. So you can pass in an environment variable. Okay. So every container will be a little different. The Postgres container requires you to pass in this environment variable. There's also other things you could do, but this is kind of the minimum that you have to do. So I'm going to do that. And then I'm also, so if I run this now, it's going to run, it's going to first off check if an image already exists locally on our machine. If it doesn't, it's going to download it. And then it will run it. When it runs it on its own, internal Docker network, which is separate from the rest of my machine. So I can't access it directly. So what I'm going to need to do is open up a port from my local machine into the Docker container. And I'm going to do that with -p. And I can choose whatever random port. I'm just going to do 5454 for no real reason. And then that's going to map to 5432, which is the default. Postgres will listen on 5432 by default. So inside of the machine, inside of the container, the Postgres is going to be listening on port 5432. I'm going to create a mapping from my local machine. If I go to 5454, it's going to forward that to this port right here in the running container. So I'm going to run this. Something strange happened there. Not sure why that. Okay. I'm going to run this. Should take just a second. Okay. So it should be running now. So if I do docker ps, you can see this container, which is running right now. And I can see that it's called, it's from the image Postgres. This is the command that ran. This is built in. You don't need to worry about that. And then the ports Let me make this a little more readable. So this is the port mapping. So localhost 5454 on my host machine, i.e. my laptop, and that's going to forward it to 5432. All right, so that container is running. So now I'm going to use my database client here to connect to that. So I'm going to go, every client will be slightly different, but it's all basically the same. So I'm going to create a new database connection right here. And I'm going to choose Postgres. And then here is where I'm going to input the specific information for my database. So the host is localhost, and that's correct. This is not going to be the default port. I'm actually going to use 5454. This is the port on my local machine. It's going to get forwarded to the other one. And the database, I think, is just called Postgres. Username, Postgres. You can look at this command. So and then the password here is going to be my secret password. So I'm going to provide that information. And then I'm going to test the connection. And it's working. And I'm going to finish. So now I have, I basically I have a nice GUI wrapper around a connection to a database. And I'm going to right click on this now. And then create, what is it? Yeah, SQL editor. So I'm going to open a SQL script. So now I can just execute whatever SQL I want to right here. I can do select star from. Now, I don't have any tables created, but there should be like a public. Yeah. And I can execute this, just this line. Postgres. Okay. Try.
You missing the semicolon?
Yeah, that's so for this you actually don't need that, but okay, so anyway, we don't have a table, so I'm just gonna forget this for now. Okay, so what we can do is we can actually create this table. So where are we here? So we have this diagrammed out. So I'm gonna translate this into SQL. So I'm gonna go right here. I'm gonna move this down. And then I'm going to run a command, a SQL command to create a table. So create table. Pretty straightforward. And then I can give it a name, which is customer order. And then parentheses. And then here, we're just gonna define the table. So similar to what we did here. So we're gonna have an ID, which is gonna be an integer. And then a name, which is gonna be varchar. Address is varchar. Birthday, an integer. Order, item. Varchar. Order number. Order item cost. And then order total. Yeah.
It's you got order item number.
Thank you. Okay, so I've got this defined. So I'm gonna go ahead and execute this so I can highlight specifically what I want to execute. So I'm just gonna highlight this and then run it. And then I get some feedback here. And I didn't get a failure, so it means it ran successfully. So now I can run a query just to make sure that that table exists. So I can do select star from customer order. And there's no rows, but I can see the structure here. So I have these columns.
So
All
what
right.
they give you, instead of creating a query like update or something, could you just go in there and update it?
I don't think you can. There there may be some editors that allow you to do stuff like that. I don't think this one does though. But so let's go ahead and insert some data. And so we've created a table, and we can get information from the table. So let's add information to the table. So we do insert into. So it's a keyword, insert into, and then you provide the table name. And then you have a couple options. If you provide values for everything, then you don't have to specify like the column names. And if you don't, then you do. So I'm just gonna skip that. And so insert into customer order and then values. Here's the data that we're actually going to supply. And so we need an ID. So I'll do 1 and then a name. Bob. What do we got here? Go back to this. Bob Jones. Anyway, we don't have to do that exactly. And then bar car 1, 2, 3 main. Birthday. Order item 1. Order item number. Day 2. Order item cost 99. Order total. Okay, so I'm gonna execute this statement now.
Order item should be a string.
Order item, yes, thank you. Be a okay, so column Bob does not exist. Has anyone had this error before? Kind of a strange error. So it's telling me that a column Bob doesn't exist, but of course the column Bob doesn't exist. I didn't create a column Bob.
Yeah, I noticed that the name was like highlighted as if it was a keyword, but I don't know why.
Yep, yeah, there's an issue here. And SQL errors are almost never all that helpful.
Single quotes.
Yeah. So double quotes, SQL reserves double quotes for columns and single quotes for strings. So that's just something you have to keep in mind as you're switching back and forth. So I'm going to make these single quotes. All right, so now I'm going to try and execute this. And that works. So I'm going to select everything again, and I should see that data there. So I've got ID, name, address, birthday, etc. All right, I'm going to do the same thing for Sally. So insert this now. And if I run the query again, I can see that I now have 2 rows. Okay, so we now have taken this, like, let's say, description of a database. We've turned it into a visual representation, and now we've actually created a real database table and inserted some data. So question now is this the best design? Can we do a little better? And the answer is obviously yes. And one of the ways we can do better is, as the name, one of the possible names we could give this table is customer order. And we can do that because there's really kind of 2 things happening here. We have information about a customer here, and then we have information about an order over here. So wouldn't it be nice if we could break out that information in 2 separate tables? And a couple reasons you might want to do that. As I mentioned, if Sally keeps ordering, then I'm just gonna keep creating lots and lots of copies of her address and her name and so on. But I don't really need all that information to be copied every single time she makes an order. So let's go ahead and pull that out. Before I move on to the next step, any questions so far?
Would you for the order total, this is
Yes.
would you get rid of that too, since it can be derived from the other columns, or would you, I mean, maybe it doesn't matter, or would you just keep it to, because it's easier, or?
Yeah, so that's a great question. I would probably just get rid of it, because just like birthday and birth year, or sorry, birth year. Oh, it looks like I forgot. Okay, so I forgot age here, but that's fine. Yeah. So order total, this is information that can be derived. You basically multiplying, in this case, the number of items they ordered times the cost. So this is information that can be derived from other information that's already there. So in generally, like if you want to normalize your database, you would want to get rid of something like this. There are, like, we're not going to really go into this, but there are reasons that you would want to denormalize data as well. But yeah, so in general, I would say you'd want to get rid of this. Okay, but we'll keep it for now, because this is still, an imperfect example. We can make more improvements. All right, so we want to extract entities now. We have one big table, which is nice in some ways, because all the data is right there. If I want to know about an order from Bob, I write one query that queries one table, and everything's right there. So let's separate this out. So I'm going to go over here to the database diagram, and I want a customer table and an order table. I think for keyword purposes, I'm just gonna let's see. I'm just gonna call this product order. Order is a keyword. Anyway, so I'm just gonna. This is just an order, but I have to give it a different name. So customer, we're gonna keep this, and then order information is gonna go over here. And that's pretty much it, I think. So now we're good. We have customer information over here, and we have a product order over here. So let's implement that in a database. So first, I'm gonna
Sorry, would you need to add the customer ID to the order table
Yeah.
or?
That's a great question. So I'm gonna kind of we'll eventually get there.
Oh,
I'm
okay.
gonna do it stepwise, but yes, that is a great point. Okay, so first off, I'm gonna drop the current table. So drop table order. Okay, and now I'm gonna start over. So I want to implement customer and order. So I'm gonna just copy this actually. And I'm gonna do customer create table order. What do we call it? Prod order. I'll take all this stuff. Okay. Execute that. I have to do this. So I'm trying to execute basically multiple commands, so then I have to include this. Okay, so I've got this table, and so I'm gonna now just make sure that everything looks right. So select star, select star from customer. Okay, so that looks good, and then select star from prod order. Okay, so everything looks okay. So I'm gonna go ahead and insert some data now. Copy this line. So insert, actually I'll just start over. So insert into customer values. And then this is gonna be, we'll copy this. And then I'll do the same thing. Insert into table with values. That, execute that. And then I also need order. So insert into order values. And then I will copy this. Okay, here we go. And execute that. All right. So now, if I want to write a query that's going to get me, let's say, Sally's order, all the information about Sally and her order, how could I write that query? So I can get everything from customer, which I can, or from product order right there. So everything's there. And then the customer table, everything's there. But now I want to get Sally and her order.
You'd have to create a reference maybe in the product order table.
Okay. Yes. So eventually we're going to want to do something like that, but for now, we just have what we have. So we have to work with what we have here. So just from a query, so how can I get that information? That's the only thing I have control over is the query.
Well, if you know what she ordered, then you could just say, like select whatever the column is from the table name, and then use a where product, I guess. Is that what the column name is? Equal lamp?
Okay, so I could, yeah, so there's a few things I could use a where clause to target a specific value. So I could either use this, the order item, the order item number. Yeah, I could choose one of these values and target it that way. But I want to get everything, not just the product, but I want to get the customer and the product information.
Would you select from both then? Or use
How do I
a
do that?
or use a join, or you wouldn't use a
Okay,
join.
join. Good. So how do I get information from two different tables?
Select
You guys are doing this all last week. How did you get information?
the star from customer, comma, prod order. That should do it, I think. And then comma, just prod order. It should get it. That should give you. It'll give you everything from both tables, I think. Yeah. And it gives it
Okay.
plot. Interesting.
Yeah, so this is, I wouldn't rely on this. So this is basically syntax sugar. What's the basic thing that we're doing? I have two tables. I want to get information from both tables.
You just
Someone's got to know this. You guys
select
are doing
star.
this. So select star will give me columns.
Hmm. Right.
I want both tables.
Is there a wild card? Or
You union.
What's that?
Can you use union?
Union, okay. We could use union, okay. So select star. So how would I, if I were going to write a union, how would I do that?
You can just repeat the syntax that you have for a customer, and after you put the keyword union, I
Okay.
think.
Is this going to work?
No, I think you have to put select. I think it's like doing two calls. I think
Okay.
Yes. Yes.
Okay. We can try this. So we
Lord.
get an error here. So union is for putting two tables together that basically have the same schema.
Gotcha.
So customer and product order do not have the same schema. You guys are absolutely killing me.
I was
I'm
thinking,
not gonna
You
play
use
the
a
end.
join, but you need something to reference on each that are the same, don't you?
So let's go back and I'm going to look at yesterday's stuff. So it looks like we have a bunch of different tables that are connected. And let's see. So how do I get information from multiple tables?
You use a join.
Yes. Yes. Use a join. That is how you get information from multiple tables. You guys are doing that all last week. So join. So select star from customer, join, prod, order. I can try doing something like this. It's not going to like it directly. And it's not going to like it in part because there are different kinds of joins. And if you don't specify the join, it'll default to inner join. So this is the same thing as writing inner join. And inner join requires something extra. So I can do something like this. What is it?
do an outer join?
There's a Cartesian product.
Doesn't want that either.
What is that called? It's cross-form. You basically never use this. And that gets the same result. So this is a Cartesian product. This is like the combination of every possible row. So each row from each table, every possible combination. So I can do that, and I don't need any kind of limiting condition because it's just going to get everything. But here, I don't want to get everything from every table. I want to join these two tables, but I just want to get Sally's information. So how do I limit information?
Using join, or do you want to go back to where?
Let's just, so you guys know about where right now. And you know, how do you limit stuff in a join?
Would you use on?
Yeah. Yep. So on is like where for a join. So join on. And then what's the join condition? How do we want to filter?
Don't we need to join it on two columns that have the same information?
You could, yeah. I mean, and that's how you will do it, but for right now, we don't have a explicit column that will let us do that. So how do I make sure that I just get this row?
Would you just kind of make it up? Like Sally equals lamp, or
Okay. On customer dot name equals Sally. Okay, so now I can limit this one. How do I limit this one?
do you use and
Okay,
then whatever it is, product or whatever the column name is it order item, I guess.
okay. So let's try this. So now we have a query and we have information from two different tables. So we want information from two different tables, so that means we have to use a join. And then we want to filter that information. And the condition we have is the customer's name has to be Sally, and the product order's order name has to be Lane. So this works, but it's obvious that, you know, as people have kind of mentioned either directly or indirectly, we're not these tables don't have the relationship embedded in them. These are just two independent tables, and we just happen to be connecting them. And if this works okay for just this one query when we know this information about Sally, but if we wanted to, let's say, get, join the table together and get all of the customers and orders together, there's not really a way to do that. So this doesn't scale, right? We have to know specific information. What we're going to do is we're going to go back to our diagram. And instead of just having two independent tables, we're now going to connect them. So these tables have a relationship to each other. So what kind of relationship does customer and product order have?
Customer orders products.
Right? Okay, good. So a customer orders products.
I mean, it doesn't have a relationship now. You have to create the relationship in product order. You need a foreign key.
Okay, good. So foreign key. So if this were instead of a database table, if these were two classes, how would you structure these classes? What kind of relationship would they have?
Be composed, classes if you're in Python.
Okay, good. So we would use composition. So we have two classes. We want to use them together. So what class would contain which other class?
Order would contain customers, I think, because a customer can have more than one order.
Good,
Order will
yeah.
never have more than one customer.
Good. So yeah, you're getting at something important there. So this is called a one-to-many relationship. So a customer, one customer can have many orders, but an order can only belong to one customer, right? Now you could set this up differently. You could imagine a scenario where, yeah, people like splitting the bill or something like that. But the simple case is that one customer can have many orders, and one order, a given order has only one customer associated with it. So if a customer needs, if an order has a customer, then we're going to add a customer ID. So we're going to add a link from the order to the customer. We can call that customer ID. And this is actually going to be a foreign key. So don't worry about this part right here. So this is just, don't worry about this. You can, learn this as you need to. But the end result is we now have a connection between these two tables. And you can see this is standard notation, this single bar here, and then this like crow's foot over here. So this is one, and this is many. So if I go from customer to product order, it's a many. So one customer can have many orders. And if I do the opposite way, from product order to customer, then it's one. So an order has one customer associated with it. So this line is the one, and this line, the crow's foot, is the many. So this is kind of standard notation. You don't like have to memorize it, but it's something you'll probably see. Okay, so we have this diagrammed out. So I'm going to jump back over here, and I'm going to do the same thing. So I'm going to drop some tables. So we're going to do this, and then we'll take a break and come back. So drop table customer. And drop table prod order.
You also use alter, it wouldn't be alter table, like, or add column, I guess.
Yeah, so we could
Add column.
definitely.
I mean, you'd have to know what the orders are, I guess. You'd have to know who ordered what.
Yeah, so we could definitely update these, but I'm just gonna start from scratch. In part because it's easier to see these. So I'm gonna copy this. And we can keep the same basic structure. It's the only difference is that now product order is going to have a customer ID, and that will also be an integer because customer ID is an integer. And then we'll use a keyword, references, and that will be customer ID. So this is just syntax that you would have to look up. So I can look that up right now. Postgres foreign key. This Postgres SQL tutorial, I think this is probably the best, clearest resource for this kind of stuff. And there's a few different ways you can do that. So foreign key references. So here's the syntax for that. You can also define everything, and then at the end you can add constraints similar to what Corey was saying. But anyway, so you would look through documentation as usual to figure out the specific syntax for what you're trying to do. Okay, so now I have this these two tables, and these two tables should be connected to each other. So I'm gonna try and create these.
Just a black screen for me.
Sorry?
Okay, now it's good. It was a black screen for me. It works now though.
Same.
Sorry, my when I'm doing Zoom recording, my computer just like slows down to a halt. So okay, so I have an error here. So SQL error, there is no unique constraint matching given keys for reference table customer. That's kind of a mouthful, but if we think about what we've done right now, we have a customer and a product order. So every time we create a product order, let's just say we have to have a customer associated with it. But what happens if we have multiple customers with the same ID? And that's going to create a problem where, you know, how do you join these two things together? And so what we're going to have to do is modify this. We have to make sure that this is a unique value.
You just serialize it.
Yeah, so there's a few ways to do it. We can, there's serial, so it's not serialized, it's serial, and it basically just will give it an auto increment thing. So every time you save, every time you create a row, it'll just increment the ID by 1. So that ensures that it's unique. You can also mark it. I think if you implicitly mark it as a primary key, it will take care of that for you. Let me just try that. Okay, so yeah, there's a few ways we could handle that. There's also a unique constraint that you can use. Primary keys, I think, implicitly makes it unique as well. All right, so we have now these two tables. So now I should be able to just copy all this stuff over. And run this. Okay, so now I have an issue. So error, duplicate key value violates unique constraint. So where is this problem?
In the customer table, they both have the same primary key.
Yep. So I tried to insert some data which violated the constraints I had set up on this table, and SQL didn't let me do it. And that's a good thing, because you don't want bad data getting inserted, because it's just a disaster. So I'm going to change this. Okay, and what's my problem now?
There's no foreign key in the product order table.
Exactly. So I can create customers now, but I've changed the columns of product orders, and I have to supply a customer ID. So let's just say 1 and 2. Okay. And so now let's select star from customer. So that works. I have this ID and I have the name, the address, and the birthday, and I can do the same thing from product order. So the question is now, how do I get matching rows? How do I combine these tables together in a query?
So you'd use the join. If you want to join, if you wanted both tables, and join. And it would be then the customer.id equals prod order.customer ID.
Okay, so we'll get everything from customer. We want to join that to prod order. And what's the condition? We want to line up customer ID product order dot customer ID with customer dot ID.
You got prod router there. Oh, look at that. What's it doing?
What's going on here? So now I get everything. So it's like I separated, we separated out these tables to make them easier to use, to reduce duplication and so on. So now, Sally can have as many orders as she wants, and we just have one copy of her data. But we want to present that information together. So we separate it out in the schema, and then when we write a query, we can join it back together. And let's say I only, from the customer table, I only want the name.
Add the name where the star is.
Okay, so star.
That should just be name.
Is it like name dot, no, customer dot name?
Okay, so customer dot name. What is customer dot name? And then I also want to get all the information from the product order.
So you'll need a comma, select customer name, customer or ID, I guess. So customer.id.
So another select statement.
No, just put a comma and just put customer I, because you're selecting them from customer.
Well, I want from
You
the
need
customer table, I only want the name. And then from the order table, I want everything.
But if you're, you could,
I've done this before, but I forgot.
Okay.
I feel like we'd want to do it opposite, kind of, right? Select star from customer order or product order.
Could you just do comma product order dot star?
Okay, we do something like that. So if we want to select particular columns, how do we select particular columns?
You like product order dot or customer ID, product order, comma, product order dot order
Exactly.
item.
Yes, exactly. So we can manually specify each column that we want, right? So you can do star and get everything. You can also specify each column. So I can do customer.name, prod order dot customer ID, prod order dot order item, prod order dot order item number. I can individually specify each column that I want. You can also do something like prod order dot
Prot rotter again.
man, I don't know what it's. I assume it's me, but everything that I'm doing is on like a 1 or 2 second delay, so I think it's messing with me. And so this is, you could do it this way, but you can always individually specify each column that you want. Okay, let's take a break and we'll come back and do a little more.
How long is the break?
Okay, so any questions about what we have so far? So we have 2 tables, customer and product order, and they are connected with a foreign key. And then we want to get information. So we are designing everything. We kind of pull things apart into separate entities. And then when we query, we can bring everything back together. Okay, so we're going to continue on this process. So if we iterate on this and go back and look at our model, is there anything here that we could pull out further? Are there any more entities here that we might want to pull out? Basically anything that's complex.
We're gonna need the address, right, for the order.
Yeah, so there are a few it's basically it's pretty open-ended, but one thing is that address has lots of components. It has a zip code, it has a street name, it has a state, it has blah blah blah. So there's it's a complex structure, so it's a good candidate to get pulled out into its own table. So I'm gonna make an address table here, and I'm gonna keep it simple, but I'm gonna do street name, bar, and state. And I'm gonna restrict this to only 2 characters. This would be like a state abbreviation. Okay.
So I was thinking.
Yeah.
So I was thinking the other day, is it easier to separate street names by lines, or would it be easier to transform the data on the front end for an address? What do you typically see?
So like if you have the address number and then a street and then like an apartment number, is that like what you're talking about?
Yeah.
Yeah, I mean, I don't work with that kind of data directly. But it's definitely one of those things where the more you look into it, the more complicated it is and the more variation there is. You think of it as being, oh, it's just an address, but especially when you're dealing with like international addresses and stuff like that, it's like it's like time. If you ever had to deal with, time or dates, it's just kind of a nightmare. It seems simple, but so I can't give you a real good answer.
So it's typically like a project level decision rather than standardized.
Yeah, I would say I'm sure that there are libraries, especially if you're doing like international stuff. But I would keep it simple. I would just break it up into, zip code, street number, maybe apartment number. Because there are also fields which are going to be optional. So this is another thing we're not really talking about, but there are like there's sparse columns. So something like apartment number. I mean, not everyone's gonna have an apartment number. Some people do, some people don't. So you'll have a lot of null values in that column.
I don't know if this kind of correlates with that. So in my job, we enter a lot of people's addresses and stuff, and it communicates with a database that the post office creates to verify like the address is a correct address or not. And it's all split apart usually by like line 1, line 2 for the street, city, state, zip, all that when we have to verify it. And if it doesn't like manually do it, you have to go in and if it doesn't automatically do it, you have to go manually do it. And it's all split apart when we do it like that. So we put it as like one line normally, but in their system, it breaks it apart and searches by all those different fields.
Well, yeah, that's helpful. So I mean, there happens to be basically an authority on what an address is, and so if they have that like an API available to you, then you can use that. Okay, so I'm gonna keeping this a minimal example. So now I've pulled out the address, so I need to remove this from customer. But now how do we connect? We now have 3 entities and address is not connected yet.
Would we want to add like the customer ID to address as well?
Yeah, so there's a couple questions to answer. One is, which entity or entities is connected to address?
You probably want both of them, right? The customer and the order.
You could potentially have a system where a customer could order something and then provide like an alternate address, which is not the home address. But let's say we're sticking with the simplest case, which is that an order gets delivered to the customer's home address every time. But yeah, so all of these questions are open-ended, and the answer really depends on the nature of the application that you're designing.
So would you link the product order to the address? Link those tables together?
We could, but my sense is that the address really is something that's associated with the customer.
Yeah. Okay.
So like, as I said, you could definitely imagine a system where you would want the address to be connected to an order. For example, if if basically an address could be different for every order, regardless of the customer.
Yeah, I got you. Yeah, sorry. I'd create an address in the customer as a reference and then tie the address to that, and then have product order go not only to ID, but to that address as well.
Okay. So some good thoughts. Let's kind of walk it back just a little bit. So we've decided that for this application that a customer and an address need to be associated somehow. So what kind of relationship? There are three kinds of relationships that you can have. There's a one-to-one relationship, which is not that common. There's a one-to-many relationship, which is very common. And then there's a many-to-many relationship.
So it should be maybe a one to many, now that I think about it, because sometimes you see multiple like addresses when you go to, you want to buy something, it says which address do you want to use.
Okay, good. Yeah, so what kind of relationship would that be, for example? If a
One to many.
So yeah, customer could have many addresses, potentially, depends on the application. And then an address, what's the reverse relationship in that scenario?
Many to one.
So an address could only belong to one customer.
I guess a mini to mini in case you have two customers at the same address, both put in orders.
Yeah, so in that scenario, I think a many to many relationship would be appropriate, because you could have a customer could have lots of addresses, and then one address could be the home of many customers. So you have like a family living together in the same address, something like that. So again, I'm going to keep this simpler. So that's an example of a many to many relationship. But let's say that we have a rule and you can only have, one address. So a customer can only have one address. In that case, it would be a one to many relationship. So a customer has one address, and an address can be associated with many customers. So the case of like a family or something living at the same address, they could all share an address, but be individual customers. So all these questions, again, very open-ended, very dependent on the specific nature of the application you're designing. But to keep things simple, because I don't want to go into many to many relationships just yet. So a customer and an address. So I know that a customer has an address, and so how do I express this?
Wouldn't you just bring the ID from the customer and attach it to address as well?
Yeah, so the question is, where do I put the foreign key? Do I put the foreign key in customer, or do I put the foreign key in address?
There should be an address, wouldn't it?
Okay, any thoughts on that? So if I put the key in address, I'll just do that right now. So customer ID, the foreign key. Over. So a customer can have many addresses, and an address can belong to one customer.
Sorry, it
That
has to
would
be
be the other way
opposite.
around.
Yeah, it's tricky, but yeah, I think it should be the opposite. Because it's the customer that has to have an address, right? Like you can have sorry. Oh, I don't have an ID here. So the other issue is I'm gonna need to create basically like a primary key field on address. So ID is. So a customer has to have an address. So an address can exist independently. I can have a bunch of different addresses in my database floating around. But if I want to have a customer, the customer has to have an address. So I think this is the right model for the made up use case we have. Okay, so we have the relationships diagrammed out. So now let's go and implement it. We'll go back here. And I'm gonna copy all this stuff. First thing I'm gonna do is I'm gonna drop customer. And we have a problem. It says error cannot drop table customer because other objects depend on it. Detail, constraint, prod order, customer ID on table prod order depends on table customer. So because of what we did up here, if I delete customer and product order has a reference, to customer, what happens to this? If I delete the table, this customer table, now I have just like this reference to nowhere hanging out on this table. So I mean, you can do that, but what you want to do is basically ensure that so that there's something called cascade. So you don't have these hanging references to empty, like basically null pointers. So I do cascade. As the actually I get a hint, use drop blah blah cascade. So now if I drop this, then anything that depends on it will also get dropped. Okay, so now I have the tables gone. So I'm gonna make this not address, but address ID. And this is going to reference address, which we haven't created yet, ID. So now I'm going to create this other table here, create table address. And what did I give it? Let's just do street name and state abbreviation. I'm going to restrict it to 2 characters. And then we need a primary key. Basically, you need a unique value. So ID int. All right.
So I think it's helpful. I was working Thursday and my database kept crashing because my tables weren't hoisted correctly. So I don't know if that's a, what's that?
Right. You mean your tables weren't defined in the right order?
Or maybe scoped is the better word.
So you're like, for example, if I put this at the bottom, it's gonna
Correct.
from top to bottom. So it's gonna say, okay, create customer, and then that references address ID, and it's gonna say that doesn't exist and blow up.
Yeah, and it took me a minute to figure it out because I didn't think you needed to do that in this. So it's kind of like JavaScript where you have to, make sure everything's where it needs to be.
Yeah. So there's another way of doing it where you basically don't include stuff like this. So you just have the tables defined without any relationships. And then at the very bottom, then you add on these like extra statements. So that's another way of doing it.
Yeah, I just thought that'd be helpful just in case anyone runs into that because I had a hiccup for like 10 minutes. I had to figure it out.
Yeah, thank you. Yeah, that's a good point. Okay, so we have these tables defined, and let me check. So customer now has this foreign key to address ID, and the product order has a reference to the customer. So I think should be good. Let me run this, create the tables. Okay. Syntax error at or near references. Again, we're in the land of very unhelpful SQL errors, but I can at least look somewhere around references. There's an issue. Just for the sake of time, I'm missing a comma here, but hard to tell what the problem actually is. Let's see, street name, bar car.
Would that details, or is that not part of the error message? That's just its own thing? That
This,
details button on there, that wouldn't help, I guess.
yeah, I'm not sure why this is being highlighted. It's giving me a different error location. This is the actual SQL error that I'm getting.
Okay, yeah. The
reference.
details, that's just its own button, and it has nothing to do with anything, or
This,
the details
Is-
here, there's a button, you got the triangle, or maybe it's
oh,
just
I see. Yeah,
icon. Maybe it's an icon. I don't know if it's.
yeah, it's not going to give.
Oh,
me
right. Yeah, okay, yeah, it's just a.
Is it because you don't have a type where address ID is? Maybe.
Very good. Thank you. So I don't have a type.
Yep.
So int, and it has to be an integer because the address ID is also an integer. So these types have to match. Thank you. Cool. So now I create all these tables. And I'm going to go insert some data. So I'm going to be able to steal most of this. So I'll create some address. We have the same issue, so I'm going to create some addresses first. So insert into address values, and then we have an ID. We have a street name. I almost use double quotes. Main Street. And then state abbreviation. I'll do one more. ID 2. Okay, so I have address. Now I create a customer, so that should be the same, except address is now going to be the address ID. So this will be 1, and this will be 2. And then everything else should be the same. All right, so I'm going to insert this data. All right, and now how do I get all of the data? So I basically just want to see long rows with everything.
You could do like the select, the inner join that we did before.
Okay. Let's look at the diagram here. So I want to join all of these tables together.
I would probably start at address, and then join customer where ID equals address ID, And then you just would have to do a second inner join again, I think, where customer ID equals where ID equals customer ID.
Okay, let's try that. All right, so we want to get everything to all the columns from, and we're gonna start at address. We're going to join customer. And how are address and customer connected?
Customer ID and what was it? Address ID.
Okay, an address ID equals customer dot. All right, so I'm just gonna, this is an intermediate query, so I'm gonna run this. Let's see, do I get sensible result? Yes. All right, let's keep going. So we got address and customer connected. Now we gotta connect product order. So product order is connected to the customer on customer ID and product order customer ID. So it is confusing with all these IDs, but that's how it is. And then join prod order on customer dot. Why do I keep doing it? Customer dot ID equals prod order. That customer ID. All right, we'll run this and see if we get everything. We have order information, we have customer information, and we have address information. Okay, let's just say now I only want to get Sally's. So I want to get everything, but only for Sally.
You could just do a where name equals Sally.
Okay, so I can do name, and that should work in this case.
I guess you want to specify customer dot name.
Yeah, so that's optional in this case because there's no other, but oftentimes you're joining lots of tables and they have common names, and so if there's ambiguity, you'll get an error. So usually a good idea to be specific. So customer dot name is Sally. And this. And now we just get that one customer. Okay, so that's the name of the game basically for this week. Is you're gonna have an application. You're gonna want to think about the kinds of information that you need, and then you're gonna want to create entities around that information, and then establish relationships between those entities.
So on the customer to address relationship, we kind of did like a many to one. How would you do a many to many?
We'll talk about that next week, but you actually have to create a third table. You can't directly express it. So you create another table, and then you have two one-to-many relationships. Okay. And we'll stop sharing, stop recording, and I'm going to go over the